situation, if we have this situation, this one in particular, how do we determine the resultant? The resultant. And last time we realized that since the forces are acting oppositely, it implies that the angle between them, the angle between F1 and F2 is equal to what? What did we say about this
180.
angle? Pardon?
180.
180. Okay. So when two or more vector quantities are acting oppositely to one another, the angle between them is 180 degrees. Okay. How then do we obtain the resultant or the effect of these two forces? Yes. Which is the resultant?
We
How
add
do
them.
more views. One feedback is that add them, another feedback is that subtract. Okay, so when they are acting oppositely to one another, okay, this is similar to when there is a table, okay, then you push and somebody else pushes from the opposite direction. Yeah, but what is go ahead. What's that a feedback you want to give us? Or it's a mistake? Okay,
If it is
go ahead.
opposite, you negate one
All right.
so that it's the same direction.
Oh, you are right. So here you subtract the least vector or force from the most vector. Okay. So if F1 is greater than F2, then the resultant will be F1 minus F2. This is similar to what Yaba is saying. You negate one, but you subtract the smaller force from the larger force. And if F2 is greater than F1, then the resultant will be F2 minus F1. So it depends on the magnitude of the forces. Please, are we okay? Are we okay?
Yes,
Yes, please.
Let's add values. Assuming F1, Yaba, give me a value. F1 is equal to F1 is equal to, pardon?
3 newtons.
3. And F2 is equal to, oh, let's hurry up. F2, Yaba, F2 is equal to
5 newtons.
5. Then the resultant will be equal to, here F2 is greater than F1. So we subtract F1 from F2. So this is 5 minus 3 Newton. And the resultant or the net is the difference between the forces equal to 2 Newton. Is that okay? Now,
yes.
what is the direction of the resultant force or the net force? The direction. When you push,
Force.
yes. You see, the direction will, in this case will be along the direction of the larger force. Thank you, Epia. Okay. The practical application of this is that if there is a box and you push and I push, and I happen to provide or apply a larger force, because the force I apply is greater than yours, I can overcome you, and the body can move in the direction of the larger force. Because I am applying the larger force, the body would move in my direction of push. Please, is that okay? So here, the direction of the resultant or the net force of the resultant force is due west. Due west because F1 is pushing due east to my right, whereas F2 is also pushing to my left. So this is the resultant will act in the direction of the larger force. So due west. Please, are we okay? Are we fine? Another quick scenario, and the scenario is this. Let me add some forces. Here we have F1, F2, F2, 1, 2, 3. F3, F4, F5.
Mr. Dear,
Hello.
please would you give us notes on vectors?
Oh, I can send you some notes, but while I take you through, pay attention to some of the information I give you, okay?
Okay.
We have three forces acting due west, three forces acting due east. What is the resultant of this number of forces acting concurrently on the mass, acting the resultant force? In a situation like this, these are values. I don't know which one is greater, which one is less. But what we do is that sum up all the forces in one direction and sum up all the forces in the other direction and subtract the least one from the larger one. So all these are going due west. So I'll sum all of them up. F3 plus F4 plus F5. When I look at the other end, F6 is also in the same direction as these forces at the other end. Okay, so I add F6 to these ones. So plus F6. Even though it is at the other end, what I'm interested in is the direction. So I look at the direction and add. So all these are forces due west. Due west. Then I look at the total forces due east. So due east I have F1 plus F2. Though I don't know the values, but I am assuming this sum is greater than this. Nana Otubia, Nana, mute yourself for me. So the net or the resultant force, please, net is the difference between the net, which is the same as the resultant. The net will be equal to F3 plus F4 plus F5 plus F6 minus F1 plus F2. So it can actually be mixed. The directions can mix up, but still, in determining the result, sum up all the forces in one direction Okay, pick it from the other end and sum up the forces in the opposite direction. Subtract the least from the larger force. Please, are we okay? Are we
Yes,
okay?
yes, please.
Example, example, example F1. Let's assume F1 is 3 Newton. I want to change the marker. F1 3 Newton, 2 height, F3 2, F4 6, F5 1, and then F6 we have 3. Let me add another force here to make it. Let me add another one which is to this direction. This is F7. F7 is 10. Now the instruction requires that I find the resultant force and the direction. So I identify all the forces in one direction from both ends. When I look at this, let's look at the forces due east. Due east. F1 is due east, so F1 plus F2 is also due east. Then F7 plus F7. When I sum them up, I have 3 plus 5 plus 10. This is giving me a total of 18 Newton. And the forces due west. Okay, due west to this direction, I have F3 plus F4 plus F5, okay, at the right hand side. And when we come here, we have F6, so plus F6. Let's put in the values. We have 2 plus 6 plus 1 plus 3. This totals, this is 7, 9, 12. Therefore, the resultant force or the net force is equal to 18 minus 12. And this is equal to 6 Newton. So the resultant of all the forces acting on the body is equal to 6 Newton. And what's the direction? What's the direction of the resultant, class?
Due east.
Due east. As simple as that. Okay. So this is it for forces moving along one plane or vectors. So it can be vertical along the vertical y-axis. It can be along the horizontal. The forces can be along one direction or can be mixed up. All that you have to do is that identify the total forces in one direction, sum everything up, identify the forces in the opposite direction, sum everything up, subtract, and you have your resultant. Please, are you okay?
Yes, please.
All right. Any question? If you have any question, you can quickly ask, else I continue. Okay, then let's look at forces acting along two planes. x-axis. Let me manage my board well. So I have x-axis, y-axis. Okay. Now, one force F1 acts along the y-axis or the vertical plane. Another force F2 acts along the horizontal plane. The relationship between these two forces is that they are acting perpendicularly. Here, all the forces are acting along the positive y and x plane. It can be both ways. It can also be negative x and then negative y. But here we have, okay, one F1 acting along the y, F2 along the x. And this is what we are calling as they are acting along two planes, along y and then along x. Over here, we had only along the x-axis. We can also have only along the y-axis, and that will be along one plane or one axis. Please, are you okay?
Yes, please. Yes, please.
All right. So if you have a situation of this sort, how do you determine the resultant? And what is a resultant force? A resultant force is, is that singular or single force whose effect is equal to the combined effect of a number of forces. So it means that what what some number of forces can do, only that single force can do it. And this single force, which can do the same work as a number of forces, is what we are defining as resultant force. Please, are we okay?
Yes, please.
All right. So if we have this, how do we determine the resultant? To determine the resultant, when you have vector quantity, okay, connected in this manner. Nanakia, your hand is up.
This was a mistake.
Okay. To determine the quantity, when you have the resultant, when you have vectors connected in this manner, the first thing you have to do is that look at the direction. Direction of F1, direction of F2. One is going here, another one is going here. Okay. The directions do not follow any sense of orderliness. This is going here, this is going here. The question is, where are they going? Okay, where are they going? Both forces must follow a certain sense of orderliness in their direction. But for what we see, it doesn't follow that order. So we have to realign or rearrange the directions of the forces so that it follows a certain sense of orderliness. They have a certain common destination. Please, are you okay?
Yes, please.
Good.
Yes, please.
So we are going to do that. We are going to arrange the forces so that their directions follow a certain orderliness. How do we do that? We do that using what we call equal vector approach. We create equal vector or vectors of both F1 and F2. And vectors are said to be equal when they have the same magnitude, direction, and they are parallel in space. So equal vectors have equal vectors have the same magnitude, direction, and they are parallel in space. What do we mean by in space? In space, what it simply means is that wherever they are, one may be here, okay, one may be here, one may also be at a far end. But so long as they have this attributes, same magnitude, same direction, and the two are parallel, wherever they are equal. And that is what we mean by in space. Wherever they are, they can be very far. But once they have these details, they are equal. Please, are we okay? So we create equal vectors. Now I'm going to create a vector which is equal to f1 equal to f2. The vector says we create the clone of this and this. So I'm going to create an equal vector of f1 and place it on the head of f2. A vector has a tail, this is a tail, and has a head. There's a head. Lizzie,
Mr. Dia, please, you said equal vectors have the same. I couldn't.
equal
My
vectors,
network.
equal vectors have the same magnitude, direction, and they are parallel in space.
Okay, thank you.
Welcome. Okay. Oh, no, I'm coming. I wish I got a straight edge. Okay. That will be difficult. Okay, so
You said and are equal in
in space, meaning
space.
wherever they are, they must be parallel. Good. So for a vector, this is the tail of the vector, this is the head of the vector. So I'm going to create an equal vector of f1, place it on the head of f2. Don't forget this is the tail of f2, same as the tail of f1, but this is the head of f2. So I'm going to create equal vector of f1 and place it on the head of f2. Okay, and in doing that, if if the magnitude of f1 is from here to this point is so x centimeter, I have to get the same thing. So drawing a vector from the head of this to this one. So if this is x centimeter, this is also x centimeter. Then the directions of these two must be the same. This is going up, and so this must also go up. Okay. Now the angle between this and then f2 is 90. So the angle between the equal component or vector of f1 and then f2 must also be 90, meaning they are parallel, because parallel lines have the same slope. Okay. Once the same magnitude, the same direction, and are parallel, I can say this is also f1. So the broken line represents the equal component of f1. Are we okay? I can do same for create an equal vector of f2, put it on the head of f1. Okay, by drawing equal magnitude as this one. Equal magnitude as this, same direction. This is moving horizontally. So this will also go this way. And this is parallel to this. This and this, the angle between them is 90. So this must also be 90. Okay. So let me
Okay.
bring the arrow at the middle. So this is F1 and this is also F2. Now, after doing this, look at what is happening. Look at the direction now. F1 is moving upward by the arrow, please. By the arrow is moving upward. By the arrow, F2 is also moving horizontal. So they all look like coming to this point. If you look at it from here, this is going here, this is going here. If you look at it from below, this is going here, this is going here. So this becomes their common point. Meaning that when you draw a vector from the tail of this to this point, it must give you the resultant of F1 and F2. A vector from here to this point must give you the resultant. So this becomes the resultant of F1 and F2. F1, this is F2, and then F1. Please, are you okay?
Yes.
And this follows a particular law of vector addition. Triangle law of vector addition. Triangle law of vector addition. Okay, and it simply means that R is equal to F2 plus F1 by the arrow, or by the direction, by the directions, we are deducing that this R is equal to F2 plus F1. And this is what we call as the triangle law of vectors. Please, the triangle law of vector does not mean that if you are looking for the resultant, just add this to this. This thing applies for only scaled drawing. Scaled drawing. What is a scaled drawing? Okay, on a scale drawing, let's assume that I give you forces. This is, oh, let me change the marker. I give you forces. This is 5 Newton. The 5 Newton force is perpendicular to maybe 4 Newton force. Find the resultant. I can draw this to scale using maybe a graph sheet or, and I say that let every 1 centimeter represents, okay, here on a graph sheet is 2 centimeter. 2 centimeter represents 1 Newton. Meaning that for this force, I'll take 8 of the boxes on our graph sheet. On our graph sheet, let's assume this is 2 centimeter. So if you are saying that let every 2 centimeter represent 1, then I have to take 8 of this. Okay, 1. Sorry, I have to take 4. 1, 2, 3, 4 to represent this 4 Newton. Okay, so 4 of the divisions on the graph book would give me this 4 Newton force. Then I also count 5 vertically to give me the 5 Newton force, because I have a scale, and the scale is that every 2 centimeter represents 1 Newton. So if every 2 centimeter is representing 1 Newton, then I have to count 4. 1, 2, 3, 4 to give me this, and then 5 of this to give me 5 Newton. Please, are you okay? Now, when I have done that, because this is to scale, then I can say that, oh, I can just draw the equal vector of this and put it here, the same arrow. Then I can just measure from here to the far end. I can simply measure from this point, use a ruler, measure from here, from this point to the other end to get the resultant. Then I can say that the resultant is equal to simply this 4 plus 5. Okay. Then I can say that the resultant is simply equal to 4 plus 5. And when I measure, it's this length from here to here must give me the same force or length of 9 Newton. So you can only use the triangle law of vectors for scaled drawing. Scale drawing, when the drawing is scaled. Please, any question?
No, please.
Now, if the drawing is not scaled, an example, what I'm saying is that we can only use the triangular law of vector addition, R, when you have realigned the directions. And then you realize that, oh, R is equal to this plus this. F1 plus F2 for scale drawing. When the drawing is, or when the picture given to you is drawn to scale, then you can use that. If it's not drawn to scale, here you have to use, you see the forces form a right angle triangle. Okay, F2, F1, and then resultant. This angle is 90 degrees, so we have a right angle triangle. So here we can use Pythagoras theorem to find the resultant. So you use Pythagoras theorem when the drawing is not scaled. You use the formula, which is Pythagoras theorem when it is not scaled. When it is scaled, you can simply add them using triangle law of vectors. That's what I'm saying. Are we okay?
Yes, please.
All right. So let's give ourselves a problem. We have two forces perpendicularly to one another. They are acting along the two planes. F1, this is 10 Newton. F2, this is 5 Newton. I'm told to find the resultant and then the direction of the resultant. Here, the two forces are acting along two planes. So the first thing is that their directions does not make any sense. So I have to realign their directions to follow a sense of orderliness, right? And that is, I can do that by using equal vector approach. So I take an equal component of this. Vectors are equal when they have the same magnitude, direction, and are parallel in space. So this is F2. I can also create another one for F1. So long as same magnitude, direction, and are parallel, this is also F1. Now, after doing that, look at the direction. This is going here, this is going here. So the resultant is simply drawing a vector from the tail to the head of this one. So this becomes the resultant because from the arrow, they are all going up here. So the arrow of the resultant must also go up. This is perpendicular to it. So you use the Pythagoras theorem, meaning r squared is equal to f1 squared plus f2 squared. What is f1? F1 is 10. So 10 squared plus f2. F2 is 5. 5 squared. This is 100 plus 25. 1, 2, 5. R is therefore equal to the square root of 125, which is
11.1
11 point 11.18.
1
So this is the resultant. Any question? Now, what about the direction of the resultant? The direction of the resultant. Okay, so with the direction, the resultant is going up here. Okay, headed to this diagonal. The direction is the angle between the resultant and then the x-axis. This is the direction. Because if I'm here and a point is here, all that I have to do to face it is turn through an angle. So when you determine this angle, you have the direction of the resultant. Okay. Now, so we have this right angle triangle. Okay. This is the opposite, this is the adjacent, and you have the hypotenuse, which is the resultant form. Here, because you have all the sides of the right angle triangle, you can use any of the trig ratios, cosine, sine, or tangent to find the direction. So please go ahead, use it, and then tell me what you have as the direction of the resultant. Okay. Yes, I'm giving you 2 minutes. Try, let's see what you come up as the direction of the resultant. Are you through?
Yes.
Testing. Now, okay, so let's see. So when I use tangent, tan of this angle, theta, tangent is equal to F2 on F1. And so I have 5 Newton on 10 Newton. This is equal to 0.5. Theta is equal to the tan inverse of 0.5. What's the tan inverse of 0.5? Yes. What? 26.
26.56.
Okay. Okay. Now, when you use sine, cosine, you get the same value because we have all the sides. So if you have two vectors and they are perpendicularly to one another, okay, you can use the cosine rule, Pythagoras theorem to find the magnitude and use the trig ratios to also get the direction of the resultant. Please, any question?
Mr. Dear,
Mhm.
please, I don't get the tan part.
The third part is that, you see, we have all the sides of this right angle triangle. This side is 10. This side is 5. We found the hypotenuse, which is the resultant, 11.1. What I'm saying is that here we are only looking for the direction of the resultant. And since you have this side, this side, this side, you can use any appropriate trig ratio to find the direction. If I want, I can use tangent, tan of the angle. Tangent is opposite 5 over adjacent 10. So I have tan theta is equal to 0.5. Therefore, if I'm looking for theta, I just would have to take the tan inverse of 0.5. And that's the answer we got. 26.6. Approximately 27. Akoso, are you okay?
Yes, please.
Somebody can also decide to use sine. Sine of the angle theta is equal to opposite 5 over hypotenuse 11.1. Divide 5 by 11.1. Then take the sine inverse. Let's see what you have.
Mr. Dear, please, how do you do the inverse?
You press on shift on your calculator, then you look for sine. Shift sine, then you key in this one or the decimal value. If it's 10, shift, you press on shift, then 10. Lizzie,
Mr. Dear, please, I got a different answer. I got 0.46.
no, maybe you didn't press it well. Okay, divide 5 by 11.1. What is 5 divided by 11.1?
0.45.
0.45. Okay, so theta would have to be equal to sine inverse of 0.45. So shift, then you press on sine, then you input 0.45, then enter. Please, let's all confirm.
You get 26.7.
Good. Don't forget we rounded this up. Okay. The whole number is what is important. Lauren, your hand is up.
Mr. Edia, please, when I did the tan inverse, I had 0.46.
Theta is equal to tan inverse of 0.5. Punch that, let's see. Tan inverse, shift, tan, key in this, and then enter. Shift.
Yes, please,
Shift.
0.46.
Then maybe your calculator is on radian. Check if there's a D, R, or G. Your calculator must be on D, degree.
This is on R.
Pardon?
Yes.
It's on R.
That's the reason why. So whenever you are doing angular measurement and your calculator is not on D, it can change your value. When you come to school, I can teach you that. Okay.
Yes, please.
All right. So you can also use the cosine. We have every part. Cos of theta. And here the cos is adjacent 10 over the hypotenuse, 11.1. Okay, and 10 divided by 11.1, this must give you 0. 0 point what?
0.901.
0.901. So theta will be equal to the cos inverse of 0.901. Okay, so shift cos, then you input 0.901.
The answer
It
is
must give you
25.7.
20,
5.7.
25.
Yes, please.
Okay.
If you run it, you
Okay.
get
But
26.
about 10 divided by 11.1, is it exactly 0.93? 0.901?
It's 0.9009.
So the running is what is causing it. Okay.
Yeah.
So take the cos inverse of the whole value and you get a value close to this. Don't round it. Are we there? All right. So when vectors are perpendicularly, the resultant is obtained by using Pythagoras theorem. Okay. So we've learned when they are two vectors are acting in the same direction, angle between them 0 degrees. Resultant is equal to F1 plus F2. When they are acting oppositely, this is here F1, then this is here F2. Here the angle between them is 180. The resultant is F2 minus F1, provided F2 is greater than F1. Then when they are moving perpendicularly, the resultant is equal to square root of F1 plus F2. Now, what if the angle between them is not any of these three situations? An acute angle or an obtuse angle. Don't forget this is 0, this is 180, and this is 90. So let's look at when the angle between them is either acute or obtuse. Can I clean this?
Yes,
No,
please.
yes, please.
So we are still on when the vectors are moving along two planes. But this time the angle between them is acute. What is an acute angle?
An angle that's 90.
Come again.
An angle that is less than 90 degrees.
Greater than 0, less than 90. So for acute angle, the range is between 0 degree less or equal to theta, less or equal to 90, theta is between 0 to 90. So this angle is any angle greater than 0 but less than 90. Okay. So the two forces are moving along two planes, one along x and one within the xy. How do we determine the resultant in this case? All right. So we have to realign the directions. Realign the direction. Because from what we see on the board, the directions do not follow a certain order. This is going here, this is going here. The question is, where are they going? So when you have a situation of this sort, you have to resolve the forces into a parallelogram. Resolve the forces into a parallelogram. That's the first thing. Okay. So when after resolving it, you need to get a parallelogram. And we could do this by equal vector approach. We create an equal vector of either F1, F1 and F2 and place it on them. So we take the equal component of F1, place it on the head of F2. Okay, so let's do that. Vectors are equal when they have the same magnitude, direction, and class complete it for me. And
Equal in space.
good. So this vector I need to draw must have the same magnitude as this, must have the same direction, and must be parallel to this one. So if the magnitude from here to here is x, from here to here must also be x. There's the direction of F1, it must bear the same direction. Yeah, are you there? Utubi, are you there? Ekuya Adoma and Co.
Yes.
So I've created the equal component of F1 and it's on the head of F2. I have to do same for F2. Same magnitude, direction, and this must be parallel to that. So the same direction as this one, same magnitude, and this must be power. Then I can also call this as F2. When you do that, now look at the order, either up or down. This is going here, this is going here. This is going here, this is also going here. So it's obvious they are all coming to this point, isn't it? Isn't it?
Yes, please.
And now we have succeeded in realigning their direction. So the resultant force is this. Drawing a vector from this point to this point. This is the resultant force. You see what we've created? We formed a parallelogram. And what's a parallelogram? For a parallelogram, interior angles are equal. So this angle, interior opposite angles are equal. This angle is equal to this angle. This must also be equal to this. The sides, parallel sides are also equal. This side is equal to this side. This side is also equal to. So we've resolved the forces into a parallelogram. Is that okay?
Yes, please.
Now, how do we determine R, which is the resultant? We could determine R using, you see this, if we look at either up or down, when you look at the downside, this also follows this triangle here, also obeys the triangle law of vectors. This is going here, this is going here. So the resultant will be this. So we can say that R is equal to F1 plus F2. But this is not scaled, so we cannot determine the resultant using this. But the arrows or the directions of the forces tells us that, oh, what we've had obeys the triangle law of vectors. Okay, either looking at it down here or up here. Okay, and because it's not drawn to scale, we can't use this to find the resultant. We have to use a formula. And this formula we are going to use is what we call, we are going to use the cosine rule. Cosine rule to determine the resultant. And so here, why can't we use Pythagoras theorem, class? Yes. Why can't we use Pythagoras theorem to determine the resultant? Yes. Yaba.
Because Pythagoras theory is used for only right angle triangles.
Good. It's because Pythagoras theorem is only used for right angle triangle. And this is not, this triangle, either when you look at it, either up here or down here, any one goes. You can use any one of them. This is not a right angle triangle, so we can use Pythagoras theorem. Please, class, are we okay?
Yes.
So we can only use the cosine rule. What is the cosine rule? Interestingly, the cosine rule also applies to all manner of triangles, whether it's right angle triangle, equilateral, scalene, isosceles, the right angle, the cosine rule works. What does it say? If I have any triangle, This side is C. This side is A. This side is B. If the interior, the angle opposite to this side is alpha, and the angle opposite to B is beta, and the angle opposite to this is gamma. Then, when I'm looking for any side, maybe C. When I'm looking for any side, maybe the side C. Then, the side I'm looking for squared, C squared, must be equal to the sum of the squares of the other two sides. So A squared plus the B squared, okay, minus 2 times the product of these two sides. 2A times B times the cosine of the angle opposite to the side that I'm looking for, times the cosine of the angle opposite to the side that I'm looking for. And what's the angle here? What's the angle opposite to the side I'm looking for? What's the angle there?
Alpha.
Alpha. So you could see that the cosine rule is similar to the Pythagoras theorem, but there is some kind of modification. Meaning C is therefore equal to the square root of A squared plus B squared minus 2AB cos alpha. That is how I can determine C. Now, if I'm looking for A, what do I do, class? Or what do I have to do? If I'm looking for A or B, somebody should help me.
A squared.
Go
A
ahead.
squared is equal to B squared plus C squared minus 2BC cos the one over there.
Thank you. You see, I asked this question because if this had been the Pythagoras theorem, if you are looking for A or B, you would have to make A or B the subject from the equation. This one is not like that. For the cosine rule, you have to go through it as you went through C. So if I'm looking for A squared will be equal to C squared plus B squared minus 2 times CB times the cosine of the angle opposite to the side A. And what's the angle opposite to the side A? What's the angle opposite to the, that's alpha. Hey, no, it's not alpha, gamma. Therefore, A, yes, A is equal to the square root of C squared plus B squared minus 2BC cos gamma. The same thing also applies to when you are looking for B. All right. Any question? Any question? Okay. So let's quickly apply that to what we have here. It means that if I'm looking for the resultant, the square of the resultant is equal to f1 squared plus f2 squared minus 2 times f1 times f2 times the cosine of the angle opposite to R. What is this angle?
Theta.
know what is this angle. There's the angle opposite to it. Theta, I will explain, but you see, if I extend this line, because this side is parallel to this side, equal vectors. When lines are parallel, it means that the angle between their slope must also be the same. So if from F1, F2 to this is theta, then from here to here must also be theta, because this is parallel to this. Please, are we okay?
Yes.
Because this is parallel to this, if this is theta, this must also be theta. So if this is theta, what then will be this angle? Yes,
180 minus theta.
good. So this will be 180 minus theta. So times 180 minus theta. Okay. So this is actually the angle opposite to R. Okay. Therefore, R would be equal to the square root of F1, F2 minus 2F1, F2 cos of 180 minus theta. Bushra, are you there? Okay. But then, there's another way of simplifying this angle. And that is, I can expand this whole angle, cos 180 minus theta. The expansion of this is that here I have two angles, 180 and theta. So let's represent the angles by letter A minus B. So 180 is A, theta is B. I just want to give you the formula for expansion of this before we apply it to this. Okay. So if I have, this is what we call compound angle, expansion of compound angle. Expansion of this is equal to cos of A times the cos of B. So it's cos. Now, if the operator here is minus, the operator between this term is plus. When this is minus, this will be plus. When this is plus, this will be minus. It's a formula. Then of A times the sine of B. This is the expansion of when you have this. So cos, this is minus. So plus sine times sine. Please, are we okay?
Yes, please.
It's a formula. So just put it that as you move ahead in physics, we'll be giving you a lot of these identities. So let's use this to expand cos 80 minus theta. What I have will be cos 180 times cos theta. This is minus 4 plus sine 180 times sine theta. Now cos 180 is equal to -1. Point your calculators and see. Cos 180 is equal to -1.
True.
Then sine 180 is 0. So because this part is 0, everything goes to 0. meaning that cos of 180 minus theta is equal to negative cos theta. So look at this whole thing within the box. Cos 180 minus theta is the same as this. So in place of this, I can substitute that to write this as square root of f1 squared plus f2 squared minus 2f1 times f2. And because cos 180 minus theta is equal to negative cos theta, I substitute that into it. So I have f1 squared plus f2 squared. Negative times negative, I have plus 2f1 f2 cos theta. So what it means is that if the angle between the forces is theta, I can use cosine of the angle theta without subtracting this from 180. Okay, but what must change is that this must change to plus. Then you could use the angle directly and you get the same results. Class, are you okay?
Yes.
So either this or that. Let's solve a question. The angle between two forces of magnitude 10 Newton and 15 Newton is 60 degrees. Do I clean the board?
No, please.
The angle between two forces of magnitude 10 Newton and 15 Newton is 60 degrees. Find the resultant force and the direction of the resultant force. Adoma, are you there?
Yes, please.
Okay.
Sir, please, can you repeat the question?
Pardon?
Can you please repeat the question?
The angle between two forces of magnitude 10 Newton and 15 Newton is 60 degrees. Find the magnitude and the direction of the resultant force. So you are looking for the magnitude and direction of the resultant.
Mr. Dear,
Hello,
please, what's the value of the angle?
60 degrees, 60.
Yes.
Okay. Can you give it a trial? Maybe 5 minutes. Think through, let's see what you can produce. You have the formula and everything. Give it a trial. Okay. So we discuss it after the 5 minutes. Finished? Hello, class, finished?
No, please.
Two minutes more. Can we look at it?
Yes, please.
All right. So, what did you get for the resultant force?
13.228 Newton.
18.
13.
Okay, so let's see.
18.
Okay. So, the forces are 10 and 15, right?
Yes, please.
So, 60 degrees is the angle between them. 10 Newton and then 15 Newton. Here, it doesn't matter which one actually comes, the order. No. Once it was not
Did you say 16 or 15?
1 5. 1 5. You had it at 16.
Yes, please.
So, oh no. 1 5. So it means that this is F215 Newton. From how it looks, the directions are not in a certain order. So I have to realign the directions so that it follows that orderliness. So this therefore would be the resultant. Okay. Once this is 60, when I extend this line, then this angle would also be 120. Because 180 minus 60. So either r squared, r is equal to the square root of f1 squared plus f2 squared minus 2f1 times f2 cos of 120. Let me put in my values. F1 is 10 squared plus 15 squared minus 2 times 10 times 15. Cos 120 is negative half times minus half. That's the value of cos 120. So 2 would cancel this. So I have 100 plus 225 plus this negative, so plus 150. When you sum up 100, 225 and 150, what does that give you? Hello, I'm waiting.
325.
300.
25. 325.
So R, what is R will be what the value of R? Square root of
Yeah,
that is equal.
we combine everything.
Mr. Adria,
Hello.
please, I got 475.
475.
Oh, okay. Just I was expecting that you combine everything. 5, 7. This is 4. So what's the square root of this?
91.8.
Oh.
Okay. Then I was also saying that I can also use the angle given to me straight. But this time the only difference is this to plus. So square root of 15 squared plus 10 squared plus 2 times 15 times 10 times 60. And for 60 is also half. So it will just give me the same result. So you can either use the angle given to you or the corresponding obtuse angle. Please, is that okay? Now the direction. Is everything
Yes.
everyone okay here? I hope everyone is okay.
Yes.
All right. The direction of the resultant. The direction of the resultant. Eh, who is just breaking my eardrum? When you look at the direction, this is where the resultant is heading towards. Okay, so here we are looking at the angle the resultant makes with the horizontal or with the nearest, the x-axis or the nearest force. You see, this force, the 10 Newton force is simply along the x-axis. So here we are looking at the angle the resultant force makes with the x-axis on which the 10 Newton force is. Okay. So it is just the small angle alpha, which is less than the 60. So let's draw it. F1 is here, 10. F2 is here, 15. Then the resultant R, we found it, 21.8 Newton. And we are looking for this small angle, which is this alpha. Don't forget, this angle is still 120. We haven't changed anything from, so this is still 120. In looking for the angle, one method of determining this is using what we call sine rule. Sine rule. Sine, S-I-N-E, rule. Don't forget, we use the cosine rule for the resultant force, and we are using the sine rule for direction of the resultant force. Are we there? Are we there?
Yes, please.
All right. How does the sine rule work? How does it work? If I have a right angle triangle, this side is C, A, B. This angle opposite to A is alpha, opposite to B is beta, opposite to A is gamma. I can take ratio of the side to the angle opposite to it, or vice versa. I can take the ratio of the side to the sine of the angle opposite to the side in question. So if it's this, C over the sine of the angle opposite to C, and that is alpha, is equal to A over the sine of the angle opposite to A. And what's the angle? Which angle is opposite to A?
Gamma.
Gamma is equal to B over the sine of the angle opposite to the side B, beta. So either you take ratio of the side to the sine of the angle opposite to it, or the sine of the angle divided by, or the ratio of the sine of the angle, ratio of the sine of the angle to the side. So it's the other way around. And this is what we are calling as the sine rule. So depending on any two available information here, you can find your angle. Let's apply it here. We are looking for this angle. So if I take sine of alpha, sine alpha over, please, sine alpha over what? Hey, Sadia, Saida, Zaida, you are breaking my eardrum. So sine alpha over what? Over the force opposite to it. What's the force?
15.
So 15 is equal to. Do we have any other internal angle available?
Yes.
Yes, please.
So the 120. So sine 120 divided by, divided by
21.8.
exactly the resultant force 21.8. Let's make sine alpha the subject. Let's make sine alpha the subject from what we have. Yes, somebody to take me through that. Sine alpha will be equal to,
Mr. Adrian,
hello.
please, the rules you've given, that mean you can interchange it.
Oh, what I'm saying is yes, either the side over the sine of the angle or the sine of the angle over the side. That's why I've given you the two different. Okay.
Okay, thank you.
So 15, uh-huh. Okay, all divided by 21.8. Multiply 15 by sine 120 and divide that by 21.8. Give me the final answer. Sine 120 is equal to sine 60. And sine 60 is equal to root 3 on 2 or 0.866. So multiply 15 by 0.866 and divide it by 21.8.
0.
So sine alpha is equal to
596.
0.596. Then alpha will be equal to the sine inverse of 0.596. What is the sine inverse of 0.596?
36.6 degrees.
Yeah, but come again.
36.6.
So approximately 37 degrees. You realize that the angle is less than, okay, the direction of the resultant is less than the angle between the forces. Okay, so the direction is 37 degrees Celsius, Celsius, 37 degrees from the x-axis. That would enable you to locate the resultant. If you are taking it from the y-axis, then you have to subtract this from 90. Okay, don't forget this angle is to the x-axis, x. If you want to find the direction of the resultant from the y, then the direction will be when you subtract 37 degrees from 90. Okay, and that will be 53 degrees from the y-axis or from the north. Please. So both ways qualifies for the direction of the resultant. Class, are we okay?
Mr. Ija,
Hello.
please would the question given be specific on how to find the direction?
Oh, usually it is direction. Determine the direction of the resultant. And sometimes the specifics can be that determine the direction of the resultant from the x-axis or from the y-axis. Okay. And sometimes it can also be in the bearing form. If it's in a bearing form, then in bearing, angular measurement is taken from the north. So this will be 53 degrees north of, this is east, so 53 degrees northeast. And this is when the direction is required in bearing. But if the question says find the direction of the resultant, it can be from the x-axis or from the y-axis. Here, you would have to be specific where you are taking your direction. 37 degrees from the x-axis, 53 degrees from the y-axis. Both, okay, any of these directions qualifies. It's correct. Have I answered you?
Yes, please. Thank you, sir.
Please, any more questions? Adoma, Epia Adoma and Epia Boatima, I don't have any questions. Okay, so what I'll do is that I will send you a question. Okay, so you can try, but please, the questions I sent to you last time, a lot of you haven't made time to submit it to. So let me say some of you, but that notwithstanding, I'll still forward to you some more questions on this to try. Okay, right after the class. So please, I think I'll draw the curtains on today's meeting here. Conserve energy for tomorrow. Okay. All right.
Yes.
All right. So bye bye. I'll see you tomorrow. Okay.
Bye.
Bye.
All right.